Hello everyone. Today we are going to explore the time value of money, a foundational idea that shows up everywhere in finance. By the end of this lesson, you'll understand how to compare the value of money at different points in time, calculate present value, future value, and use these tools to make smart financial decisions. And time plays an important role in the value of money. For example, if you had a choice between receive $1,000 today or $1,000 a year from now, most people would choose today's $1,000. His amount is the same and the time is different. Yeah, most people would prefer to receive today's $1,000. Why wait to receive the same amount? So time make difference in our decision. Why today's $1,000 is better than next year's $1,000? Because with today's $1,000 you can spend, or you can save, or invest, and money will start to grow. If you save today's $1,000 after a year, it will grow more than $1,000. So what is the equivalent amount of today's $1,000 next year? It must be higher than $1,000, right? So the answer to this question is called future value. Since anytime from now is future, we need to specify future. Future value in year one, we use FV1 denote. So how much today's $1,000 will grow after year? That's the answer, right? The answer depends on the interest rate. Assume the interest rate is 10%. Assume if you save, if you invest, you earn 10% a year. So today's $1,000 will grow 10% into this amount, 1,000 plus 10%. So this was 1,100. And I want to relate this, use associate principle, 10%. Just the original amount at 10%. So what about after 2 years? What is today's equivalent amount in year 2? Follow the same logic, today's $1,000 after year grow to this amount. Then after another year, that means you earn another 10%. So it will grow into this amount. This is called future value in year 2 of V2. So based on year 1 amount, you plus 10%. So 1,100, 10% of 121, you add it back to 1,100, so 1,210. Again, I want to rely on this use associate principle. 1,100, 1 plus 10%. But we know this 1,100 is FV1. FV1 equals this. So to replace this, So this is FV1 1100, then you need to multiply. So what about year 3? What is today's equivalent amount in year 3? Follow same logic. Yet it should be difficult. You just need to multiply this factor. So FV3 will be 1000 multiplied 1 plus 10% to the third power. So here we have our first formula, future value, single cash flow formula. With today's any amount at any given interest rate, any period from today, its future value can be found by using this formula. So this is our future value for single cash flow formula. We call this expression as time value, future value interest factor. Let me go down. So this is denoted as future value interest factor. What does that tell us? That tells us how much $1 will grow in the future. This is like exchange rate, enable us to exchange today's $1 into future equivalent amount. Pretend we live in like today's present view or future view, like two country have a different currency. We cannot compare them dollar for dollar, just like a US dollar and a British pound. You cannot compare the value without converting them into a common currency. So same thing is true. Money occur at a different point in time. We cannot compare dollar for dollar. We needed to find their equivalent amount at a common point. Okay, so this is our first formula, future value of a single cash flow formula. Given today's any amount at any interest rate, anytime in the future, we can find its equivalent amount in the future. So let's look at an example. If you save $1,000 today, and if you can earn 5% every year, after 3 years, how much will you have at the end of the 3 years? Today's $1,000 after 3 years. So the question is asked, what is the future value in year 3? So we can just substitute in this formula. Today's amount, PV 1,000, interest rate 5%. When you do calculation, you need to convert percentage into decimal format. And to the third part, 3 of these factors, right? Use your calculator, you figure out this is 1.158. We call this is future value interest factor at 5% and 3 period. What does that number tell us? That means if you save $1 today, after 3 years, $1 will become $1.158. What about $1,000? You just multiply $1,000. We mentioned earlier this referred to future value interest factor. It is like exchange rate, enable us to exchange today's dollar to future equivalent amount. I have a table for this posted in Canvas on the time value money table. So first table is future value interest factor table. So you can either use table or use formula, and another way is use financial calculator. Here, if you know it's a future value of a single cash flow problem, so given today's amount, given interest rate, given number of period. So you can get this future value interest factor from appendix A. It's in Canvas. So here in this case, the same number, sometimes slightly different, as the difference is due to the rounding error. So this is the future value of a single cash flow. The procedure is called compounding. Oftentimes we need to deal with problem in reverse. We know future amount, we want to find out today's equivalent value to that future amount. So that is the present value concept. For example, you need $80,000 in 10 years. You need to decide how much you need to set aside today. So it will grow to 80,000. For example, you have a 10-year-old, today is his birthday, and you want to open an account, put an amount of money there, make sure the money will grow to 80,000. So when your son turns to 18, he can take out the money and spend when he goes to college. So the question is how much you need to prepare today. So it will grow to $80,000. So this is like a question, the problem. In reverse, previously we deal with knowing today's amount, find future equivalent amount. Here we know in future amount, want to find today's equivalent amount. So the answer to this question is present value concept. So with future value formula, to find the present value, we knowing the future amount, knowing interest rate, number of period, we can find a PV, right? So actually this is our present value formula. Actually, it's not completely new. We just rearrange this, knowing future amount and interest rate. So present value actually equal future value divided by future value interest factor, as a denominator is future value interest factor. But I want to rely it this way. When you divide by number, it is equivalent to multiply inverse of reciprocal of number 1 over that number. So we refer this expression as present value interest factor. So to find how much you need to set aside today, so make sure it will grow to $80,000 in 10 years. We assume you can earn 11% interest. So very straightforward. Future amount and divided by future value interest factor. 80,000 divided by future value interest factor. Whether you use calculate or use table, you get 2.839. So 80,000 divided by 2.839 is 28,179. So you only need to prepare this much. If you deposit this amount in your bank, assume you can earn 11% after 10 years. It will grow to 80,000. So we see this is a present value of 80,000 in 10 years. Yeah, the two has equal value. You prepare 28,179 today, it will have 80,000 wait for you in 10 years. So present value of a single cash flow. So far we introduced future value of single cash flow. These two as our building block. With this, we can solve a lot of complicated time value of money problem. Yeah, we also can use the table. Find the present value is, you go to the present value interest factor. This is like exchange rate. Now this time you exchange future dollar to today's equivalent amount. Yeah, you can exchange US dollar to British pound. You can exchange British pound back to US dollar. So the exchange rate to exchange rate, one is the inverse of the others. This one is the inverse of others. Yeah, we also have a present value interest factor table. That is Appendix B. We go to table, look at 11% 10 period, we find it's 0.3522. We know a dollar today was more than a dollar tomorrow. In other words, a dollar tomorrow, $1 in the future, if you want to convert today's equivalent amount, it's less than $1. That's why all the numbers are less than 1. So here 0.3522 means if you save 0.3522 today, it will grow to $1 in 10 years. So if you need $80,000 in 10 years, you just multiply 80. Answer is the same. Yeah, slightly different because of a rounding error. You shouldn't worry about that. Okay, so the future value, single cash flow, present value, single cash flow are our building block. With this, we can solve a lot of complicated problems. Next, I want to introduce a concept, annuity. We actually deal with annuity quite often in real life situation. Annuity are the multiple cash flow. They are equal amount, equal distance. For example, your car loan payment, $300 every month for the next 5 months, next 5 years, 60 months is an annuity. Your mortgage payment is an annuity. For example, let me hide this. Instead, same lump amount sum to accumulate $80,000, you decide to save $5,000 every year for the next 10 years. How much you will accumulate? Well, this enough for your daughter to go to college? Assume you can earn 12% every year. So my question is, if you save $5,000 every year for next 10 years, how much you accumulate at the end of 10 years? Of course, the answer depends on the interest rate. Here we assume interest rate 12%. So the answer to this question is the future value annuity concept. In this case, there's 10 cash flows, so there's a future value of 10-year annuity, 10 period annuity. So can we figure out how much? Yeah, with our building block, we actually able to figure out this. How? Yeah, we even though here's a 10 cash flow, we treat them one by one. So we look at how much is the first, how much is the first 5,000 will grow. So this is future value single cash flow problem, right? Yeah, don't forget about other $5,000, just the first $5,000. So how much it will grow after how many years? If you save $5,000 at the end of the year, until end of 10 years, that's a 9-year difference, right? So this is future value. 5,000 is our future value single cash flow formula. 5,000 and the interest factor is what? Is 1.12% to the ninth power. I want to follow this. Make sure here. So you substitute interest rate as here's 12%. 0.1312 and n is 9. It's not 10, it's 9. Why? Because the distance between end of year 1 and end of year 10 is 9 years. So let's figure out. So the first 5,000 will turn to 865.39 if you round to the cents. So what about second $5,000? So second $5,000 will grow to how much? So it's a single cash flow future value problem. So 5,000. This time 5,000 and here everything the same, but to the 8th power. Why 8? Because end of year 2 distance between end of year 2 and end of year 10 is 8 years. Can find this. So the second 5,000 will grow to 12,379.82. And we can do the third one, fourth one, and the ninth one. Then add them all, and then 10th one. Add them together. But for ninth one, yeah, here we. So here then we do third one, fourth one, fifth one, seventh one, eighth one, ninth one. I use the same method for ninth one, you know. So from end of ninth year to the end of 10th year is a distance only 1 year. So the interest factor is 1 plus 0.12. To keep it consistent, I also wanna highlight with red. So this, the ninth one will be 600,000, and the last one 5,000. You know, if you close your account by the end of 10 years, it hasn't earned interest. So you add all these 10 together, it's the answer to my original question. If you save $5,000 each year for 10 years, how much you accumulate? Of course, yeah, we can find this, but it is very time consuming, right? You find the future value of every of these 10 cash flow. The good thing is we have a shortcut formula. Mathematician help us to find future value annuity. Let me see. Shortcut formula, general formula for future value annuity is this. Yeah, because annuities are often associated with mortgage payment, car loan payment. Here's PMT as a short for payment. We often use PMT to represent the size of annuity. Yeah, R is the interest rate, N is how many cash flow. Yeah, this is the future value annuity formula. So you doing this one by one is equivalent to do this here. Here's a 10-year, 5,000. Yeah, R is 0.12 and oh no, it doesn't come. Do it again. PMT 5,000 R 0.12 and 10. No. Again, 0.12. So just one formula will solve the problem. Again. So you'll end up at 80,000, 743.68. Yeah, if you do one by one, add together, you'll get a number. May not be exact same, but very, very close. They're supposed to be same. If different because for rounding error. So this is our third formula, future value annuity formula. With future value annuity formula, you can solve problem like if you like this, they save equal amount year by year, how much money you accumulate in the future. Of course, you given interest rate needed to be given. So if you save $5,000 each year for next 10 years, if you can earn 12%, you'll end up more than 80,000. You end up with 87,743. Okay, last one we'll talk about present value annuity. I want to start with this example. For example, you need a freshman student attend a university, anticipate he's going to need $10,000 every year for next 4 years to complete college education at a university. Needed to pay beyond $10,000 after scholarship financial aid, still need additional $10,000 every year. Yeah, this bill needed to be paid. $10,000 at the end of the year for the next 4 years. And his rich uncle said, "Oh, no problem. I will provide." So her uncle said, "I will take care of this. I will take care of your needs. Every year I will send you $10,000 so you can make your bill payment." Yeah, so uncle can send him check at the end of the year, $10,000, $10,000. So will meet his needs. Another way is the uncle can just provide money today, write a big check, and the student can put money in bank account. Then every year withdraw $10,000. So question is, if uncle wanna write a big check today and make sure this amount will enable the student to withdraw $10,000 a year for the next 4 years, what is the amount? So the answer to this question is present value annuity concept. The amount uncle provided today is equivalent to provide this. Yeah, we talk about present value is today's equivalent amount to future cash flow. So what is how much uncle should provide today? We know the amount is less than 40,000, right? Because 40,000 spread over 4 years. But uncle is going to give you money today. Today's every dollar is worth more than $1 in the future. So how can we do this? Yeah, follow the idea how we figure out future value annuity. We treat them for cash flow, a group, treat them like as a single cash flow, one by one. Yeah, we figure out in order for you to have $10,000 next year, how much uncle needed to provide. First one, yeah, instead uncle write you one big check. Let's say uncle is going to write you four check. First one, you put it in 1 year CD, make sure it will grow to $10,000 after year. Second check you put in 2 year CD, make sure it will grow to $10,000 in year 2. And third check, you put in 3 year CD, make sure it will grow to $10,000 in year 3. Fourth check, make sure you put in 4 year CD. Make sure it will grow to $10,000. So let's figure out how much first check, second check, third check. So this is actually the present value of each of these single cash flow, right? Assume you can earn 12%. So what is the amount of first check? So you actually need to find the present value of next year's $10,000, right? So you can use formula 1 divide it. Is that right? So let me do this first one. So if uncle gave you 8928.57. So if you put this in 1 year CD, it will grow to $10,000 after a year. Right? Oh, this is just the present value of $10,000 in year 1. What about the second one? So second one is the present value of $10,000 in year 2. So you discount it. This time is square. Yeah, if I want to do better, let me copy this. So replace, this is, here's a 2. Yeah, let me write this. Yeah, this is fine. So how much the present value of second is $10,000 is about 7971 7972 about 7971.94. You may get slightly different number. It's okay. It's because of a rounding error. Okay, what about third check? So you discount it by this time to the third part. So the present value of this third year's $10,000 is 7117.8. Okay, last one. What is the present value of $10,000 in year 4? This number becomes smaller and smaller. 10,000. So lastly, let me start here. This is the last one. So we discount this, we find the last present value of 10,000 in year 4 is 6355.18. Then we add them together. Is okay? Yeah, if uncle write full check, first check will grow to $10,000 in year 1. Second one, 7971 will grow $10,000 after 2 years. Third one will grow to $10,000 after 3 years. Last one will grow to $10,000. Yeah. But why uncle need to write 4 different checks? he can just write one big check. So one big check is what? You just sum all these four. Sum these four. So let's add them together. 8, 9, 2, 8. And that's the one. So if I didn't make add together is 30, 37, 3.49. Let's double check. Okay, so yeah, if uncle gave you this today, you put it in bank. If bank give you 12%, you can withdraw $10,000 every year for next 4 years. Last one, after last withdrawal, your account balance becomes 0. Yeah, if you don't believe, you can verify that. You know, you deposit this amount today. After a year, how much it will grow 12%, right? Then you take 10,000 out, leave the remaining money there. It will earn 12%. Until when it reaches year 2, then you take $10,000 out, leave the remaining there. So it will grow another 12%. By the end of year 3, you take $10,000 out, the remaining amount will grow 12%. By the end of fourth year, it will just grow to $10,000. No more, no less. So this is we rely on the present value single cash flow. We figure out this, but it takes us a long time, right? But good news is we also have a shortcut formula. We don't have to do one by one. So this is a general formula for present value annuity. Again, we use PMT to denote the size of annuity. As a formula become more complicated. So if you substitute PMT with 10,000, substitute R with 0.12, substitute N with 4. If you do correctly, you'll get the same answer. If it's slightly different, it is because of rounding error. Okay, we are here. The general present value annuity formula is similar to what we said earlier. This expression is referred to present value interest factor annuity. This tells us the present value $1 annuity. So